Hello everyone, welcome back to my channel codeWithKhan. So if you are new to my channel, please subscribe to my channel. Let's see today's LeetCode problem 1 by 36. Minimum swaps required to arrange a binary grid. It's easy mark. Let's read the question. Given an n-to-n binary grid, in one step you can choose two adjacent rows. So we can choose adjacent rows of the grid and we can swap them. A grid is said to be valid if all the cells above the main diagonal are zeros. So return the minimum number of steps needed to make grid valid are -1 if the grid cannot be valid. The main diagonal of a grid is the diagonal that starts at cell 1, 1 to cell n, n. Okay, so what it is saying is, so from 1, 1 to n, n. So this is our main diagonal. So all the cells above this diagonal should be 0, right? All the cells like this one, this one, this one. So all the cells on this main diagonal should be zeros. Then it is considered as a valid binary grid. Okay, now let's see the constraints. So constraints are, it is n into n binary string, so number of rows are equals to columns, and n is up to n less than or equals to 200, and grid of y is either 0 or 1. Okay, now let's see this one example. Okay, where we have given 0 0 1 and then 1 0 0 and then 1 0 0. Okay, so what they are doing, so if this is our main diagonal, so we should have all zeros, right? We should have all zeros above this diagonal. Got it? Now initially we have this, and this is our main diagonal, right? This is our main diagonal. So what they said is, we'll swap row 1 with row 2. So we'll swap these two rows, right? So now it become 1 1 0 here and then 0 0 1 here. So third row remains same. Okay, this is one operation. Next operation is, we will be swapping row 2 with row 3. So we are swapping these two rows now. So what happened, 1 1 0 came here and 0 0 1 came here. So the first row remains same here. Okay, now this is one operation. And in third operation, what we did, we swapped row 1 with row 2. So now the array, grid became 1 0 0 and 1 1 0 here, and the third row is same here, 0 0 1. So now if we observe, what is our main diagonal? This is our main diagonal, and if you see, we have all zeros above this main diagonal. So this is considered as a valid binary grid. So how many operations it took? So from here to here one operation, from here to here one operation, from here to here one operation. So total it took 3 operations to convert it into a valid binary grid. Okay, so we just need to find the how many minimum number of operations we need to convert that into a binary grid. Okay, now let's see how we can approach this. Okay, so let's see, we have a grid initially 0 0 1 and then 1 1 0 and then 1 0 0. So this is our grid. Okay, and we consider this as our main diagonal. Okay, let's mark as rows, row 1, row 0 1 and 2, and then this is our 0 column 1 and 2. Okay, so now if you see how many zeros we required for row 0, so after this diagonal cell, this is our diagonal cell for row 0, how many zeros we require? We require 2 zeros, right? We need 0 here and 0 here also. So here we require 2 zeros. Okay, for row 1, how many zeros we required? So this is our diagonal cell. After diagonal cell, how many cells are there? 1 cell. So we required only 1 0. Okay, fine. And for row 2, how many zeros we required? this is our diagonal cell. After diagonal cell we don't have any zeros, no other cells, so we require 0 rows, right? So we just need to find how many zeros we need. So we need, for first row we need 2 trailing zeros, right? After diagonal we have 2 cells, so we need 2 zeros. For row 1 we have only one cell after our diagonal cell, so we require 1 0, and for here we require 0. So what we'll do is we'll try to find any rows, we'll try to find any rows with these trailing zeros. So if there exists, that means, so we can find an answer, right? So first thing is we will check all rows, right? All rows if there exists with required trailing zeros. So we'll check if rows exist with these trailing zeros. So once what we'll do, we'll take one trailing zeros array initially of length n, right? 0 1 and 2. So what we'll do is we will take the trailing zeros for each row. So if you observe, how many trailing zeros we have for row 1? So there are no trailing zeros here, so it ending with 1. So row 1 has 0 trailing zeros. And how many trailing zeros are there for row 1? So we have 1 trailing zero. So for row 1 we have only 1 trailing zero. And for row 2, how many trailing zeros we have? We have 2 trailing zeros. So for row 2 we have 2 trailing zeros. So if we observe, the required trailing zeros has 2, 1 and 0. And the trailing zeros exist are 0, 1 and 2. So by seeing this, we can say that there exists an answer, right? So now we need to see, after that, we found that there exists an trailing zeros with the within the rows. So what we just need to do is we need to simulate, right? We need to check how we can swap the rows. So it is mentioned that we can only swap the adjacent rows. So we cannot swap this row with this row, we can only swap with adjacent rows. Okay, now let's see how we can approach this. So now we have created this trailing zeros array, right? So row 0 has 0 trailing zeros, right? Row 0 has 0 trailing zeros, row 1 has 1 trailing zero, and row 2 has 2 trailing zeros. Okay, now what we'll do is we'll iterate the rows, right? Starting from for int I is equals to 0 to I is less than n, and then I plus plus. We'll iterate these rows. Okay, we'll check for row 0 how many trailing zeros we require. So required trailing zeros we will get. So required trailing zeros how we'll get? If by seeing this row 0, how many trailing zeros required? So after our diagonal cell, how many cells are there? 2 cells are there. That means 2 trailing zeros required, right? Here we already fetched 2 trailing zeros required. How we are doing that? So after if we remove n minus I minus 1, we will get the required trailing zeros. So for row 0, how we can see that 3 minus I is 0 and minus 1, so which is 2. So it requires 2 trailing zeros. So we can see the remaining cells by using this formula. N minus I minus 1 gives us the remaining cells, so that is 2. So what we'll do is we'll try to find 2 within this trailing zeros array which we are previously built. Okay, how we'll do? We'll take j is equals to I. So we'll try to find this value from starting with j. Okay, what we'll do? We'll take another while loop and we'll check j is greater than n, so it should not exceed the index out of bounds. So, and we'll check did our trailing zeros, right? Trailing zeros array of this j should be less than our required, right? What we'll do is we'll try to find, do we have any trailing zeros that satisfies our required trailing zeros? Okay, if it is not, right, if it is not satisfying this condition, then we'll proceed further. So initially we require 2 trailing zeros and we are currently at row 0. So Does this match this condition? Is 0 less than 2? True, right? We require 2 trailing zeros, but row 1 has only 0 trailing zeros, so we cannot find this. So what I will do, we'll just increase further. So we'll come here, we'll check, does row 1 has 2 trailing zeros? No, row 1 has only 1 trailing zero. So what we'll do, we'll proceed further. So we come here. So once we came here, we'll check, does this row has 2 trailing zeros? Yes, it did. So it has 2 trailing zeros. So what we'll do is, so once we found a row with the required trailing zeros, what we'll do is, we will try to just swap this with uh, the row where we are currently standing. So currently we are standing at row 0, right? We are currently standing at row 0, and we found a row with the required trailing zeros. So we required for row 0 requires 2 trailing 0, and we found that row at row 2. So what we'll do, we'll swap this. So we cannot directly swap, right? We cannot directly swap row 0 with row 2. So what we need to do, we need to swap adjacent values. So we'll swap initially with 1 and 2, and then 0 and 1. Okay, so we'll write that logic while j is greater than I, right? We need to swap till I from starting j. So what we'll do, we'll swap j and j minus 1. So we'll swap these two and then these two. Got it? And while swapping, we will take a variable called answer, right? Initially it would be 0. So initially we will be doing one swap with this one. So swap will be 1, and then we'll be swapping these two. So now it becomes, so 2 1 for the first step, and the second swap it will become 2 here, it will become 0 here, right? We did total 2 swaps, so answer will become 2 here. Okay, now we found for row 0 it requires 2 trailing zeros, and we found that row and we swapped that. Okay, now what happens, now we'll proceed further. We come to the next row, which is 1. Okay, how many trailing zeros that first row requires? So this row requires 1 trailing zero, right? This row requires 1 trailing zero. So this row requires 1 trailing zero. How? 3 minus 1 and minus 1, which is 1 only. So this requires 1 trailing zero. So now we'll do the same thing. So j becomes 1 here, and we'll see, do we have any row with the trailing 0 as 1? So currently we are standing at here, and we will check, does this satisfies our condition? No, it has only 0 trailing zeros. So we'll proceed further, and this row has 1 trailing 0, right? Trailing 0 is less than 1, so 1 is less than 1, false. So we found a row with the matching trailing zeros with matching condition. So what we'll do, we'll swap the things again. So we'll swap this index 1 with index 2. So it will come 1 here and it will 0 here. So since we made one swap, we'll add 1 to the answer. Okay, now we'll proceed further, and we will coming to this row 2, and we'll check how many required trailing zeros. So here it requires n minus I is 2, 3 minus 2 minus 1, which is 0. It requires 0 trailing zeros, and we have exactly 0 trailing zeros at index 2. So we can simply do continue from here. We can proceed further. Okay, and it proceed further. I becomes 3 and condition fails, 3 is less than 3. We only have 3 rows. So we already found our answer, which is answer is 2 minus 2 plus 1, which is 3. Got it? Okay, so now negative scenario is, so if we don't have, for example, manlo required is required rows are required trailing zeros are 2, but we have if we have 1 also here, right? If we have 1 also here, the required becomes 2 1 0 only, right? We require 2 trailing zeros here, 1 trailing zero here, 0 trailing 0 here. But how many trailing zeros we have? Initially we have 0 here, and we have 1 here, and we have 1 here. So this is not matching with the required trailing zeros, right? So in that scenario, we'll just return minus 1. Got it? Okay, now let's see the time complexity. Time complexity is to generate these trailing zeros, we are iterating the grid. So that takes big O of n square, and iterating the rows from 0 to n, and finding the trailing zeros from j is equals to I to n. So that is also takes, here it is n and here also it is n, so n cross n is n square again, so which is n square. So total it will take big O of n square. And what is the space complexity? Space complexity, we are using an array of length n to store the trailing zeros, so which is big O of n again. Okay, now let's try to write code for this. Let's take int n as grade.length, and then let's create one array, integer array called trailing zeros to store the trailing zeros, is equals to new int of n. Let's copy this since we are using this a lot of times. And then what I will do is we'll calculate the trailing zeros by iterating the grade. Int I is equals to 0, I should be less than n, and then I plus plus. And while iterating here, we'll take int count. For each row we need to count the trailing zeros, and count will be 0 initially. And from int j is equals to n minus 1 to j should be greater than or is equals to 0, and then j minus 1. So we will be calculating the trailing zeros from the end of the row. So we'll check if grade of I and j is double equals to 0, that means we'll increase the count, else we'll break. Since if we found 1, then we'll break it, and once we break, we'll update the trailing zeros of I is equals to this count. Okay, so here we found the trailing zeros. So what is our mission next? We need to check our if trailing zeros has the required zeros for each row or not. So we'll take int answer is equals to 0, then we'll start from int row I is equals to 0 to I is less than n, and then I plus plus. So we iterate each row. So first we found the required zeros. Required zeros is equals to n minus I minus 1. Okay, so we found the required zeros. What we'll do, we'll iterate into j is equals to I to till the end. We'll try to find the if you have a trailing zero or not. So what I will do, I will take while, so j is less than n, so we'll this is to check initially it is in the range or not, and then we'll check. So we'll ignore the zeros which are less than the required. So what we'll do, here trailing zeros of j, so it is less than the required. So what we'll do, we'll just ignore those things. We'll proceed further. So if it exists, that means we found a trailing zero, or it can be possible that we traverse till the end. So what we'll do is we'll check if j is double equals to n. If it reached to the end, then we'll directly return minus 1. So if it did not and it stopped between, that means it found a trailing 0. So what we'll do, we'll swap the trailing 0 now with the current row. So what we'll do, we'll try to swap till I from j. What we'll do, we'll take temp variable is equals to trailing 0 of j, and trailing 0 of j is equals to trailing 0 of j minus 1, then trailing 0 of j minus 1 is equals to temp, and then we'll decrease j, then we'll increase the answer. Okay, now once that is done, we'll need to just return our answer. That's it. Now let's try to execute this code. Yeah, it is accepted. Let's try to submit it now. Yeah, it is accepted. If you like my content, please do like, share and subscribe. Thank you.